How to find vertical asymptote. Here are two examples to illustrate how to find vertical asymptotes. I have taken them in the factored form. Mainly the reason is that I want to just share with you the concept of finding vertical asymptotes, right? Not trying to impress you by doing a difficult question at this time. Okay, here is the first example. R of x equals to 1 over x minus 2. Now, when will you get vertical asymptote? You are going to get vertical asymptote if denominator is 0. And then, when is the denominator 0? So you can equate x minus 2, which is in the denominator, as equal to 0, and we get x is equals to 2. So if I substitute x with a value of 2, I'll get 2 minus 2 as 0. And 1 over 0 is not meaningful. And therefore, at that point, we have a vertical asymptote. That means in the domain of the function, we can have all real numbers except for x equals to 2. Well, the equation of vertical asymptote is, we'll say vertical asymptote is at x equals to 2, correct? If I have to show it on a graph, then it will look something like this. So at x equals to 2, we will have vertical asymptote. We will draw a line like this. And this equation is x equals to 2. This point here is 2. Is it okay? This point is 2. We can always draw the reciprocal function here, and if I extend the problem to include the sketch of r of x, then I can take a point 3 here, 1 unit away from 2. So if I plug in 3 here, so 1 over 3 minus 2 will give me 1. So at 3 I'll have a value of 1, correct? Similarly, I can take a point 1 unit away from here, and at that point it will be, if I put in 1 here, 1 minus 2 will be minus 1, and so 1 over minus 1 will be minus 1. So I'll get 1 point here. So I'll get a graph of reciprocal function which is translated 2 units to the right. Correct? This value is also very important, the y-intercept. Here the x is 0. So if I plug in x as 0, I get minus 1 over 2. That means minus half. So if this is 1, that is going to be half, right? So I have a graph of 1 over x kind of translated. So I'll just sketch the graph here for the time being. And as you approach the vertical asymptote from negative side, you approach negative infinity, right? So that's the kind of graph which you expect here. Okay, but I hope you understand the concept of finding vertical asymptote in the first place. To find vertical asymptote, what should you do? Equate denominator to 0. Okay, so let me write this. So you have to equate denominator to 0. That's it. Here, next function, f of x. We'll do the same thing. We'll equate denominator to 0, and we get x plus 2 times x minus 2 equals to 0. So if you equate x plus 2 equals to 0, say x plus 2 equals to 0, you get x equals to minus 2. And if you equate x minus 2 to 0, we get x equals to 2. So at x equals to plus minus 2, we have vertical asymptote. Just as in the last case, I'll try to show you here on a graph. So here we have vertical asymptote at minus 2. So let me draw here minus 2 and one at plus 2. This one, let's say, is at plus 2, correct? So this is minus 2 for me, and this is plus 2 for me, correct? Now, so first part, the main question is how to find vertical asymptote. I hope you understand that part. You have to simply equate denominator to 0. You may not get such a simple situation. your denominator may not be in the factored form, in that case, you need to factor it, right? Once you factor it, you can always find the values of x. If it is a quadratic equation reciprocal, you can use a quadratic formula. If it is a polynomial, you know the techniques to factor a polynomial, right? Okay, so do adopt those techniques to factor your denominator and find out the values which will make it 0. Those values will lead to vertical asymptote for a reciprocal function, okay? For a rational function, however, there could be different situations which we will discuss in the next video, okay? To complete the graph here, if you plug in 0 here, you get minus 1 over 4, correct? So at 0, you have minus 1 over 4. So that's your point at 0, right? And as you approach minus 2, you will be approaching infinity, correct? That's the vertical asymptote. Remember, reciprocal of a negative quantity is always negative, and reciprocal of a positive quantity is always positive, right? Here, the best point to consider is, it is to go 1 unit away. So if you go 1 unit away, so you get a point 3. So plug in 3 here and get the y value. So 3 plus 2 is 5, and 3 minus 2 is 1. So you get 5 here, so 1 over 5. So 1 unit away, you go 1 over 5, very, very close to this, correct? So we can just draw 1 over x kind of a function. Remember, behavior of any of these reciprocal functions is like 1 over x, okay? So some critical points help you, and these are the critical points. You can go 1 unit left, right, and get your points, right? And then and x-intercept. So these are good enough points to sketch a graph. And you know, reciprocal of a quantity which is very small but positive will be very large and positive. And reciprocal of a quantity which is very small and negative will be very large and negative, correct? So use those concepts and sketch your graph. Now, the question here is, will every reciprocal function have a vertical asymptote? Think about it. There are situations where you may not have any discontinuity even in a reciprocal function, or the discontinuity may be of a different kind. Example, a whole, right? Here are 2 questions for you to try, and there you will figure out that you may or may not have a vertical asymptote. Try it out. The solution is given in the next video, okay? Then go through the next video and try to understand different scenarios where a reciprocal function or a rational function may or may not have a vertical asymptote. I hope you enjoyed the video. Thank you.